Well, hello everybody. This is Randy Riddle, and today we are going to review the journal article Cattle Manure Amendments Can Increase the pH of Acid Soils. This journal entry was recorded. Well, hello everybody. This is Randy Riddle, and today we are going to review the journal article Cattle Manure Amendments Can Increase the pH of Acid Soils. This paper was published in the year 2000, and it was written by Whalen, Chang, Clayton, and Carefoot. So the purpose of the study was to measure the ability of cattle manure to increase the soil pH in acidic soils in Alberta, Canada. And the reason why they did this is because there's been an increase in beef cattle production in the area, and there's a need to find a use for the excess manure in the area. If it's not used, it can cause groundwater contamination, leaching of nitrates and other nutrients into the water table, which can cause problems. So they want to determine if the cattle manure can be used effectively to manage soil pH. And they also wanted to measure the effects of extractable soil nutrients, including nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, aluminum, and iron. And their third objective in this study was to measure any changes to the CEC, mainly due to carbonate and bicarbonate buffering of acid soils. So moving on, we'll talk about our methods, or rather their methods for the research. So they sampled 2 locations, one with the Beaver Lodge soil, which has about 20% clay. They measured 28 grams of organic carbon and had a pH of 4.8. And the second site was the Fort Vermilion soil, which had 12% clay, 34 grams of organic carbon, and a pH of 5.6. So they sampled the upper 15 centimeters at each location, and they also collected samples for each treatment type. Each sample had 100 grams of oven-dried soil, and it was mixed with 0, 10, 20, 30, and 40 grams of oven-dried manure. So that was mixed together into a composite sample for each treatment type. Each sample was saturated to 70 to 75% of fuel capacity, and they were stored in sealed containers. And that's important. We'll talk about that later. And they were incubated at a constant temperature at 25 degrees Celsius. And they had 4 replicated samples for each treatment type. And they were measured at 2-week increments of 0, 2, 4, 6, and then finally 8 weeks. This is a list of the analysis that was completed. We won't talk about them all right now. However, the highlighted bullet at the bottom is important, was that they actually ran out of soil sample to run saturated paste for each replication. So they actually had to mix the replicated samples together for a composite sample to measure the bicarbonate and carbonate concentrations through saturated paste method. And we'll talk about the importance of that in a little bit, but that does create some problems with modeling some of the results. So here we have a photo of the Beaver Lodge soil results. As you can see, there were, on the left here, we have some ammonia and the nitrate results, and there was an increase immediately, and it decreased over time. The bottom section is post-incubation at 8 weeks. All the way on the right, talk real briefly, the manure had bicarbonate in it, and you can see very clearly the top row was at 104, and then it jumps up to 172 immediately. So there were additions of bicarbonate in the manure application. The Fort Vermilion soil is similar, except the nitrate column here. We had an actual decrease immediately of nitrate concentrations at the Fort Vermilion site. It was actually followed by an increase in the bottom section. So those were the main differences between the two sites. We'll briefly summarize some of the results. There was an immediate increase of soil pH that was measured, and it persisted over the 8-week incubation period. And each 2-week increment that pH was measured, it increased over time. Now, I don't have a picture of the graph for that in the presentation. But the Beaver Lodge soil increased from 4.8 up to 6.0, and Fort Vermilion increased from 5.5 to 6.3. And also the availability of mineral nitrogen concentrations increased with the manure amendment. And those tended to be higher with the larger application rates, such as 20 or 40 grams of the manure. We briefly touched on this on the last set of slides, but in the Beaver Lodge soil, the nitrate and ammonia decreased over time, over the length of the incubation period after the initial spike. And the authors contributed this to denitrification processes and immobilization. For the Fort Vermilion soil, there was over the incubation period, there was a net increase in nitrates and a decrease in ammonia, like the Beaver Lodge soil. For availability of exchangeable phosphorus, potassium, and magnesium, there was an immediate increase of availability, as you would expect with manure applications, and these were significantly higher with the larger application rates. The sulfur was mostly unaffected with their manure application, and same with CEC. It did not change significantly during their 8-week trial period. So just to discuss some of the results in more detail, we already mentioned that there was an immediate and persistent pH increase. It never decreased. It consistently was rising throughout the period. And the author speculates that it's dependent on soil properties and the source of the manure. Now, some of their justification and research in the past, they had studies that indicated that there were decreasing pH values over an 11-month period, and those were in calcareous soils, and I believe the manure also had calcium carbonate as opposed to bicarbonate. So this is a very specific set of soil and manure properties that were being evaluated, so they may be specific to the area and something to keep in mind when looking at the results. One of the big takeaways is the bicarbonate concentrations that were measured in the soil after the incubation period only represented 5% of the measured pH increase, and that was calculated based on how much carbonate would need to be added to the soil to reach the pH increases. So it only represented 5%, so the increased pH has to come from a different source. And the authors speculate that it's coming from organic compounds such as the carboxyl and phenolic hydroxyl groups. But we need to watch out at these results, because if we remember, we spoke earlier about the composite samples that were used for the bicarbonate concentrations in their saturated paste analysis. So this could have been an oversight or just lack of planning, or something happened where they didn't grab enough samples for each treatment. So they had to composite all of the samples. So there's no replication for that information. So if it was a bad reading, it could throw off the data. We wouldn't really have any statistical data to confirm it if there were any outliers. So we have to take these values at face value, and we just hope that they're accurate. So the last slide we just talked about the 5% representation of bicarbonate, but we have no way to verify that because there was only one value that was taken. So we'll continue our discussion. There was a net decrease of nitrate and ammonia detected in the beaver lodge samples. And again, the author speculates this is because of denitrification and immobilization or volatilization of gaseous. And one thing they didn't mention in the paper, and I suspect may have been an issue, was the incubation method in the containers, because they used a closed and sealed container. So this could potentially cause some sort of anaerobic condition, depending if they got the saturations correct, or just from the respiration processes of the microbial activity. So that's something to keep in mind when we're looking at some of the nutrient and the nitrogen concentrations that are represented here. So the good and the ugly. The good was that they were looking to represent increases in pH in acidic soils, and they accomplished that. And they were also able to prove that the manure was increasing the pH rather than just the carbonate that was in the manure. And they also were able to measure increased concentrations of the ammonia and the nitrate in the soil. The CEC did not change as it had in other studies in the past. However, this was a shorter incubation and trial period, so that could change over time. But in the short 8-week period, they had consistent data with that. And I thought the ugly was the lack of foresight to sample enough to run replications for the bicarbonate concentrations, because that's really what what their results come down to. They were comparing the amount of bicarbonate it would take to buffer the soil to a certain pH. However, they only had one set of analysis, so it would have been much stronger supported had they had replications for the saturated paste analysis. So for uses of this study, this is a very useful study that they conducted, mainly because there's a need in the farming community, because they have this excess of cattle manure that you have to get rid of without contaminating the soil, so it just doesn't pile up and become a problem. So if they were able to prove that you can substitute to some degree cattle manure to raise your pH instead of just spreading lime on the field, or have some sort of ratio, this would be a very worthwhile venture to pursue. So this research, unfortunately, does not give us any sort of rates or meaningful rates that we can use to for application rates for farm fields. But this can lead on to a further study. But they were able to confirm that at least that the manure was increasing the pH is what they were looking for. And also it adds nutrient benefits, which is what you would expect with the manure application. And I would like to thank everybody for your attention. Have a great day.